I've been asked if I can walk through this valve timing diagram and try to make a little bit sense of it. It is incredibly confusing, and I absolutely agree. Once we walk through it though, hopefully it'll make a lot more sense and be a little easier to understand. The first step we need to talk about is those numbers up there. All those degree numbers are not written in stone, they don't need to be memorized, and they do change. This may be for one series of engine, and a different series is going to have totally different numbers in it. Even in the same family of engines, you can change the camshaft to have different durations and different valve overlaps to give the engine different properties. Make an engine pull a little harder at low RPM or pull a little harder at high RPM. So the biggest thing with this is we just kind of need to walk through this circle and understand a few basics of engine fundamentals, and that's what we're going to do. So I think what we'll do is start at the point of the piston coming up to top dead center at the end of the exhaust stroke. We have to start somewhere in the circle, so I think that's a pretty good place to start. Let's give that a go. So here we have the piston coming up to top dead center on the exhaust stroke. This is where we're going to start our circle. So at 25 degrees before top dead center in this example, again that number is not important, the intake valve opens. So the piston is still traveling up, but it's slowing down because it has to change directions and head back down the other way for the intake stroke. So this is a great time to open the intake valve. This is going to do two things for us, one of which is to get the airflow started into the cylinder in the right direction. Air has mass, it has weight to it, so that means inertia affects it. So we need to get the air to move before the piston starts going down, and that will provide us with a better fill in the cylinder. The piston is traveling down in the cylinder. It reaches bottom dead center, changes direction, and starts coming up. At about 30 degrees after bottom dead center, the intake valve closes. So the piston's physically moving up in the cylinder with the intake valve open. And that causes a lot of confusion for some people in that wouldn't the air be pushing back out the way it just came in? And if that piston moved too far, absolutely it would. The thing we need to remember is the intake valve, we opened it early to get the air, the inertia in the air to go into the cylinder. Just because the engine's moving so fast, we need the air to start flowing before we actually need the air to start flowing, if that makes sense. The same thing happens at the bottom of the cylinder. The piston slows down and changes direction and starts to climb up the cylinder, but it's still moving relatively slow. During that time, we've created a low pressure area in that cylinder, or got a lot of air moving into that cylinder, so there's a lot of inertia there in the intake runner leading up to the intake valve. The air is moving very fast, which means it has a lot of inertia. So that piston at the bottom dead center changing directions and that fast airflow into the cylinder actually aids in filling the cylinder. It's kind of like a natural forced induction type of thing. The trick is we need the intake valve to close before the piston is accelerating too much and pressurizes the air and pushes it back out the intake port. So in this example, we're closing it at about 30 degrees after bottom dead center. So if I look at my intake duration on that one, I got 25 degrees plus 180 degrees plus 30 is about 235 degrees duration. So these are different numbers. Again, a very normal duration number. So right now the intake valve is closed, the exhaust valve is closed, the piston is climbing, and we're nearing top dead center. That is our compression stroke. Near the top of top dead center, we've added in when the fuel injector fires. Again, it is before top dead center, so we're injecting fuel while the piston is traveling up. We do this for a few reasons. It gives it some time for the cold fuel to warm up to the air temperature and auto-ignite, and that'll allow the pressure to build while the piston changes direction, so we can reach maximum cylinder pressure at about 25 degrees after top dead center. In our example here, fuel injection stopped at about 25 degrees after top dead center, and that totally depends on engine load. It may stop even before. If an engine's idling, it might start at 5 degrees before top dead center and finish at 1 degree before top dead center. Just depends on engine load. The more engine load we have, the more fuel we need to put into the cylinder to keep the engine at that RPM or accelerating. So the fuel is in here, but it really doesn't relate to our valve timing diagram. I just wanted to show you how the fueling relates to the valve and the cycles. The piston travels down on the power stroke, and at about 45 degrees before bottom dead center, the exhaust valve opens. So maximum pressure in the cylinder is about 20 to 25 degrees after top dead center. As the piston travels down the bore, the pressure in the cylinder rapidly drops. After about the 90-degree point, the engine is no longer producing much power. The pressure in the cylinder is low enough, the engine's not producing a lot of power. 45 degrees after that, there's still a lot of pressure in the cylinder, but not enough to overcome the load of the engine. The exhaust valve opens at that time. When the exhaust valve opens, the pressure in the cylinder aids in evacuating the exhaust out of the cylinder. So again, getting that air that has inertia, getting it moving in the direction we need it to move. The piston reaches bottom dead center, starts back up towards top dead center, and it reaches top dead center. When it reaches top dead center, the exhaust valve is still open, and as the piston travels past top dead center, in this example about 15 degrees, the exhaust valve closes. And that is the top of our scavenging stroke. And that's, again, to aid in getting that nice clean air to evacuate all that exhaust gas out of the cylinder. At the top of the scavenge stroke, both the intake and exhaust valves are open. So the intake opened in our example 25 degrees before top dead center, and the exhaust valve stayed open till 15 degrees after. So we have 40 degrees of crankshaft rotation that both valves are open. Now if you think about it, the piston is pushing up on the exhaust. The exhaust is just screaming out the exhaust valve into the exhaust runner. The air has inertia, it has a lot of speed to it, so when the exhaust rushes out past the valve, it'll actually create a lower pressure area behind the valve in the cylinder. So if we can have the intake valve open at that time, we now have a low pressure area in the cylinder even with the piston coming up. So that will get that intake air moving into the cylinder, increasing its inertia. So we're getting our better charge out of that. At the same time, that nice, clean, cool intake air is cooling the cylinder off and getting rid of all of the excessive exhaust gas, so we have a nice, clean burn for good power and volumetric efficiency. I hope this makes sense. If there's anything else in here that does not make sense, just shoot me a comment in the messages, and I will try my best to get to them as soon as I can. Thanks for watching.